Good morning, students. Good morning. Checking if you can hear me and see the screen. Anybody? Brandon, can you hear me and see the screen? Haley?
Yes, sir.
All right, good. Good morning. All right, let's just go straight into it. I want to practice some of these vectors questions today and to solidify and confirm and cement that we are doing the right thing in class. All right. I always say if you can do it in the class, then you can do it in the exam. So this is one of the questions I sent you last night. It is the January 2024 exam paper. That's last year, January. And this is the vectors question. It is number 10. So vectors is always one of the questions, well, part of the last question on the exam paper. That's what they set it on paper 2. It's also on multiple choice. All right. Now this question says, in the diagram below, O is the origin, and it says OE is 2 times EF. So this length is 2 times this length. All right. So basically, there are 2 of these inside here, 2 of them. Now, to get the relationship, what I usually do, one way to get the relationship quickly, because you want to know, in the end, you want to know what fraction this is of the entire line. Because remember, we're treating vectors as if these are roads that you have to go along to go from point to point. All right? Treating them as roads that you have to travel along. Right? Treat the vectors as if they are pathways, distance and direction to go from point to point. If you treat vectors that way at this level, you can get through the topic easily. All right? And this is a way to tell us what fraction OE is of the full length OF. So if you notice, in this question, they're telling us the vector OF right here. So they've given us the full length vector. But we would want to know what part of that vector is the E, the OE. And a way to do that is to put this information on the diagram. Right? So what they said is that this length EF, EOE, sorry, has 2 EFs in it. So look at it this way. This is 2 EFs, and this is a 1 EF. So the total length of the line is 3 EFs. 3 EFs, 2 plus 1. Right? So it means that the line is in the ratio 2 to 1. So if we drop off the EFs, then the total length of 3 parts is broken down 2 to 1. Alright? So the ratio of the line is 2 parts to 1. Now if it is 2 parts to 1, the total length of the line is 3 parts. It means that this is 2/3 of the entire line. So this is 2/3 of the entire line. And this is 1/3 of the entire line. So I want to establish that. And therefore, if the entire vector up here is D, then the vector from O to E is 2/3 of the D. And the vector from E to F is 1/3 of that D, for a total of D. 2/3 plus 1/3 is a whole. Anybody understand what I just did? I'm going to do it again. To break down that ratio and see the pattern. I want to do it a quick and easy way. Let me do it one more time. So the information is that this length EF has, this length OE, sorry, has 2 EFs on it. That's what they mean. 2 EFs is in that length. So what I'm doing, I'm putting what they said about this line on the line itself. So this is 2 EFs. And this is also EF, so it is 1 EF. So the total length of the line is 3. If I erase this part, the EFs, mean that this line has 2 parts to 1 part. Right? And the total parts on the line is 3. 2 parts here and 1 part here. 3 equal parts total. But there are 2 of those equal parts here and 1 right here. So the total part is 3. Then this part is 2/3 of the entire line. Right here is 2/3 of the line. 2/3. That's this piece. And this piece is 1/3 of the line. And so the overall vector all the way up here is D. Then this is 2/3 D. From here to here is the vector 2/3 D. And from here to here is 1/3 D. 1/3 of the entire D. Alright? So we can practice breaking down those ratios, this kind of information, into the fractions that they are. So this is 2/3 of D. This part right here is 2/3 of D. From O to E is 2/3 of D. And from here to here is 1/3 of D. Because you always want to kind of know what the vector is between points. You want to know what the vector is between the points. It's good to know the vector from here to here. And good to know the vector from here to here. You know that the entire thing up to F is D. D. That's what I said. Alright? So we did that information. Then here now it says M is the midpoint of EG. So this line, M is the midpoint. So that information is here, right? So that's okay. But also say now the vector EG is C. So the vector from here to here is C. So what I've done so far is populate the diagram with the information as much as I can. Alright? I don't yet know this vector. Remember, the vector is like a road. I don't know it yet. We might need to find it. Now, let's continue. The first part said, the question says, find in terms of the small c and the small d, in simplest form, the vector fg first. Now, I said in the class, if you know the portion vector of the points, you can use O times the last minus O times the first. We know the portion vector of the f is right here. I know the portion vector of the g is right there. We know the 2 position vectors. And once you know the 2 position vectors, then you can use O times the last minus O times the first. You don't need to use a diagram. You use a diagram to go from F to G if you did not know the OG and the OF. Use that method and use that approach to these questions and you're good to go. So because I know the OF and I also know the OG, I'm going to use OG, which is O times the last, G is the last, I do that first, minus OF. F is the first. So it's O times the last, G is the last, minus O times the first. F is the first. So that's OF. Alright? The OG is the C right here. Minus the OF. The OF is the D all the way up here. Or D that they gave you here. D. So that is your FG right now. So, what I said to the students again in class is, know that you know FG. It is almost like we now know this vector over here. We now know this road. FG. It is equal to this. We now know it. And therefore, if there comes a point in the question where we need to, for example, travel a quarter of the way, then it will just be a quarter of this. If you have to go half of the way for some reason, like to come to the midpoint here, it should be a half of this. And if you have to go 2/3 of the way, maybe like all the way down to here, it should just be 2/3 of this. Alright? The point is we can now go along that vector, that line, FG, because we have the vector FG, if needs be. Alright? Just bear that in mind. Let's continue. They also want the vector EG. Let's look at it. EG. So, do we know the portion vector of E? Yes, it's on the diagram. It's right here, O to E. It's 2/3. It's 2/3 D. And do we know the portion vector of G? Yes, it is the same one out here, the C. So because I know the portion vector of the 2 points, remember the OE is on the diagram now. So if though they didn't state it inside the wording, I have it on the diagram. I worked it out. It is 2/3 D. Because I have those, I can use this. OG minus OE. O times the last minus O times the first. G is the last, so it's O times the last minus E is the first. So that is it. And what is the OG? It is C. It becomes C minus. What is the OE? It is 2/3 D. 2/3 D. I should be underlining these common letters as I told in class. Underline the common vector components and put a capital letter on top when they are expressed like that, the endpoints. So this is the vector now, EG. And again, what it means is that we can now travel along this vector EG right here. We can travel along here because we now have this EG. So, for example, if we need to go from E to M, which is half of the EG, then it's just half of this thing down here. We can now go along EG if we want to, using this EG vector that we just found. So it's like we now have this additional pathway that we can use. We can go along that way. We can go the full way if we want using this. Or we can go a part of the way, like for example here. Or we can even go from M to G, because M to G is still half of this. Right? The only thing I say to you guys is that since we have this pathway in this direction, down, always try to go along that pathway in the same direction down. Because if you're going in the opposite direction, you're going to have to introduce the negative on that and put minus. Alright, so you try to go around the road, go around the diagram in a way that will take you down this pathway because that's what you know. Alright, so you don't have to be worried about introducing the negative. Alright, these are little tips that will help you to get through these questions easier. So play about the video and listen to what I've said. Alright, let's continue. Then it wants the vector OM. Let's look at it now. OM. So the vector OM is from here to there. It's a position vector O want to know, O to M. Now, in this case, we're going to have to use a diagram to get the vector OM. We're going to look and say to ourselves, let me do it in blue. I've been doing the question in red. We should be doing it in blue. Let me change these to blue. Let's change them to blue. Alright. So now we want to find this vector O to M. Now you can't find it using a calculation method right now. Right? So I'm saying, you just use the diagram and say, how would I go from O to M? Going along the vector directions that we know. What are the vector directions that we know? We know this. And we also know along this road. So basically know this as well. That's half of the full thing. So to go from O to M, we can go from O to E first, right here. And then go from E to M. That's the easiest way now to go from O to M. Going along the vector direction that we know. So that's what we're going to write up. O to M. See here now. O to M is the same as going from O to E first, using this vector, and then, based on the diagram, we're going to go from E to M, right there. E to M. That's how we're going to go from O to M right now. The E to M, we know it is 2/3 D. We're going to relieve it as this first, O to E. Plus, but the E to M is half of the vector that we know, half of this that we just found, half of the EG. So we're going to write that for the EM. We're going to write half of the EG, where the EG is this vector, so we're doing half of that. And then we can put in the values, because we have to give the answer in terms of the small c and the small d, remember. So the OE based on the diagram is right here, 2/3 D, 2/3 D, plus half of this. We're taking half of that. We take half of this part first, which is half C. Sorry, half C. And then you take half of this. And if you do half of 2/3 becomes 1/3, right? So you're going to put minus 1/3 D. That's what it is, right? So let's simplify. So it becomes half of C, that's the only C term there. Half of C. And then 2/3 D minus 1/3 D give you 1/3. 2/3 minus 1/3 is 1/3. So get plus 1/3 D. And that is it. Now, I can check if this answer is correct. O to M, I can check if that answer makes sense. If O to M is in fact this, let me copy it up and put it on the diagram and show you how we can check if this answer is correct. Let me copy it. Alright? Let's check on the diagram if that answer makes sense. Let's look at it this way. Let me erase this for you now. Zoom up and show you what I'm talking about. So let me do it in purple. The check that I'm going to do if this answer here is correct. If this answer makes sense. I want to check if this answer makes sense. So this is saying, going from O to M, I must go half of the direction of C and then go 1/3 in the direction of D. Alright, what is now? Now, this is a whole C right now. I want half of it. Half of that C will be able to hear. So this purple line is a half C right now. Alright? So this would represent half of C right now. Then I need a 1/3 D. This is the length of a 1/3 D, you know, this right now. Remember we said that that's a 1/3 D? That's a 1/3 D. So I'm gonna move this 1/3 D. Let me see if I can get it like this. Here we do. I'm gonna move this 1/3 D and put it here. At the end of the half of thing. So it's not quite a half, but you get the picture. This is a half C to here. This is half C. And this is your 1/3 D. 1/3 D. So a half C and a 1/3 D is taken from O to M. That's what this sketch is showing me. Half of a C. This is half of a C. This is half of a C. And then a 1/3 of a D combined to take me from O to M. That's why I know that this answer is correct. That answer is correct. But I can appreciate that. I just did. To do a little check. But I go do that. Somebody needs to answer, you know. Need more information?
Sir.
Good. So that's how you can check your answer, guys. Just look if the answer makes sense. Just look at that from O to M, looking for half C plus a 1/3 D. You would take it from O to M, and it does in this diagram. And so that is how I know that the answer is correct. Alright, I can trust this answer right now for OM. Makes sense. I think that's the end of this question. That is it. So this question didn't ask for the collinearity and anything like that, but that is it. Maybe I should leave those markings that I just did on the graph. The half C, leave them up there. Let me see. Leave them on it. The half C and the 1/3 D. This is the half C. Half of the whole C is that. This is a 1/3 D. This length is the same as this length up here. Same direction. That is half C plus 1/3 D takes it from O to M. So that's why this answer is correct. Alright guys, that is it. So let's look at the 2023 paper now. So I want to do maybe 4, 5, or 6 questions, something like that. That's a number of questions, about an hour and a half, something like that. That's a few questions. 2023. So here we're looking at the vectors question on this paper now. Alright, here we go. Let's look at what this one says. Let's look what this question says. Alright. So this question says, in the diagram below, OPQ is a triangle. Where is it? OPQ. See it here, so? That's a triangle that they gave us. And it says ARB and OAQ are straight lines. So this is a straight line right here. And this also is a straight line. Alright? So for example, these points are collinear. And these points are collinear on a straight line. And you can see these points are collinear as well. Hold on, let me just take this car. One sec. Hello? I'm in class. Alright. Alright. Then it says B is the midpoint of PQ. This is the midpoint of this line. Alright? Remember that. That's the midpoint. R is the midpoint of AB. So this line AB, this is the midpoint, alright? So remember, the midpoint like an average point. Treat the midpoint like an average point, right? So this R divides this line half and half, and this B divides PQ half and half, right? This is what it says. It says OR to RP is 1 to 3. Let's put those ratios on the diagram now. And 1 to 3 means that you have a quarter and 3 quarters. Because the total parts and this is 4. 4. Let's put on the diagram. So O to R, or OR, this piece is 1 part, right? OR is 1 part of the line. 1. And RP is 3 parts of the line. This is RP. Is 3 parts of the line. Total parts on this line now is 4. So from O to P up here is a total of 4 parts. Where you have 1 of the part down here and 3 of the parts down here. So as a fraction, this little piece is 1 over 4 of the line, 1 quarter. So this is 1 quarter of the line, and this is 3 quarters of the line. 3 over 4 of the line as a fraction. So whatever vector O to P is, this is a quarter of that vector, and this is 3 quarters of that vector. And what is that vector? Easy. The whole vector is 4A. The whole of this vector up here, so it's 4A. 1 quarter of 4A is A down here. So we can put on those vectors now. And 3 quarters of 4A is 3A. So based on that, I can put on these vectors quickly. So the vector from O to R right here is 1 quarter of 4A, which is just A. So the vector from here to here is A. It's like a red vector, right? Let me zoom it up. This vector here is A. I'm going to move this quarter. Move this quarter out of the way. Right, it's somewhere different. So this vector right here is A. And this is 3 quarters of the 4A. Because the whole thing is 4A, you know. And this piece right here, so it's 3 quarters of it. So the vector from R to P right now is 3 quarters of the 4A, which is 3A. So the vector from R to P is 3A. So you see from O all the way up to P is 4A. A plus 3A is 4A. We watch over the video and practice to break it down this way, guys. Then it says OQ is AB. From O to Q is 8B. Let's put down all of this is 8B. Alright, so that's the information we have. So I've broken down this 4A on this line. When you can do that, do it. Do it, break it down, because you want to see the vector between each point. The more you can see the vector between the points is the better. From vectors at this level, it's just basically how you move around from point to point using the vectors that you know. Alright? Think of it that way, keeping it simple. That's what we know. Now, this question is asking for the vector PQ. And as I always say, look if you can use O times the last minus O times the first. What is this? That we know the position vector of the P, and we also know the position vector of the Q. So no problem, we don't need to use a diagram to find PQ. It is O times the last minus O times the first. So it becomes OQ minus OP. When you can use that, you use it. The OQ is 8B. So this is 8B. Minus the OP is 4A. 4A. Alright? So they gave me the small a and the small b as bold letters. I'm underlining them on my diagram. So I need to underline this b right here. Right? I underline the a here, underline the a here, and I underline the b and the a here. So that is your vector PQ. How do we think about this now again? It is as if we now know this entire road. We now know this entire vector. It is equal to this. And therefore, if we want, we can travel any fraction of this now using a fraction of this. So for example, we can come halfway to B using half of this thing. Good, it's not complicated. All right, it's not complicated, guys. It's simple as that. Now that we have found the vector PQ, we can go along it using this or a fraction of that. All right, let's continue. I must always have that thought process if you want these questions to become easy, because most times after you find this vector, they're going to ask you a question that needs you to be coming along this pathway or the whole way or a part of the way. That's how these questions are set up. When you practice them a lot, you will know and you will realize that. That's what the question wants us to find. They want us to find PR. So do we know the portion vector of R? We know the portion vector of P, you know. We have it already. OP is, what was it again? 4A. But do we know the portion vector of R? Let's see. It's R right here. Yes. PR, or the diagram is showing us. It's easy. PR. We'll break it down already. So the vector from here to here. P to R. So it's on the vector 3A, but in the opposite direction. So it's just simply minus 3A. That's another beauty of breaking down your diagram. So it's minus 3A. So this don't need any work. It's on the diagram straight. So it's just minus 3A. Why is it minus? Because I'm going in the opposite direction. So from P to R, you're going in the opposite direction to this 3A, which takes it up that way. So if you go in the opposite way, it is minus this vector, minus 3A. That is it. What do go with that? What, okay?
Yes, sir.
Sir.
We want to go from R to B. So do we know the portion vector of R? No, we don't know the portion. Yes, we know the portion vector of R. Sorry, we know it. Yes. But do we know the portion vector of B? No. We don't know OB. It was not given to us. And as I said to you, we're trying to find RB, you know. We know the portion vector of R, but we don't know the portion vector of B. So we're not going to use O times the last minus O times the first when we have a diagram. Since we have a diagram, all we need to do is look at the diagram and see how we go from R to B. And you want to go along the vector direction that you know. We want to go from R to B right now. So to go from R to B, based on this diagram, I'm going to use this vector. Remember, you know, we know this road. Remember, so we know this road, you know. We know it from here, so you know. Remember, you have to remember that we know this road because we'll calculate it. So to go from R to B, it's simple. I'm going to go R to P first up here. And then go P to B right here. Where that P to B is just half of the PQ. With the PQ now is this. Simple as that, you know. So let me work it out up here. Where the diagram is right in front of us. And then we'll move it down. Alright? Let me work it out up here. So that is it, guys. To go from R to B, set it up like a vector equation, which is basically like a pathway, like the path that you're taking from R to B. You have to go along the vector directions that you know. So we're gonna write up like this. Going from R to B is the same as, remember, equals in vectors means it's the same as. It's the same as going from R to P first, and then going from P to B. That's what we do. We go from R to P up here first, and then we go from P to B down here. That's what the diagram is showing us. The diagram shows us that we can go from R to B that way. The RP is obviously just 3A right there. So that don't need any calculation. So this is the 3A. Right? So that is 3A right now. But the PB is half of PQ. It's obvious. This PD is half of the whole thing that we know. So it becomes half of the PB that we know. Of the PA, sorry, that we know. The PQ, half of PQ. Half of PQ that we know. Alright? That's what it is. So if we populate this now, we're going to get the 3A. And then we're doing half of this PQ. Half of that PQ is half of this value and half of this. Now half of the 8B is 4B, and half of the minus 4a is minus 2a. And this consolidates into 4b, and 3a minus 2a is a. So it's 4b plus a is the answer I'm getting for RB. Let me copy this down, and then now we're going to check it. Let me just move this down. I'll copy it down. And then we're going to check it on the diagram if that answer makes sense. So that's what we're getting right here now. That's what we're getting right here. Let me make it a little smaller. 4b plus a. Let's check if this answer makes sense on the diagram so we can accept it and move on. This is correct. So this answer is saying, this answer right now, I'm going to circle it for you. I'll move it up. Come on. That's the answer that we got, right? We got 4b to go from R to P. It is saying go 4b plus 1a. Let's look at it. 4b plus a. Alright? Now, we need 4b plus a. So it is saying RB is 4b plus a. Alright. So 4b is basically half of this whole thing. Half of that. So I'm going to just draw a line which is about half that length. Go right here. So that will represent a 4b. Right now. And we already know that a is this length. This is a whole. This is a. So I'm going to mark this as a. That's an a. Alright? So I'm combining these two now. So, see here now, if I take this one and start from B with it. Oh, it's not selecting everything. I'm selecting and select it. So. Good. Start right here with it. That's my 4a. And then from there now, I'm going to add in this a to it. I'm going to add in this a to it now. Add this a to it. See? It takes me. This is like a sketch of it, you know. So, if you're not 100%, you can still appreciate it. Right? You can still appreciate it. It confirms it in a sense. That it confirms it that 4a, and that's about a 4a, plus a takes it from R to B. And therefore, I can accept this answer right here. I can accept this answer. No, I'm saying you don't need to draw this on the exam, you know. I'm just saying you can just use that to do a little check if the answer that I get is correct. Look, if a 4b plus a will take you from R to B, and it does on this little sketch right here. So you can accept that answer. It makes sense. The answer makes sense. Remember, in vectors, anything you get by calculation must match what the diagram is showing you. That's why I love about diagram vectors questions. You can check your answer if it makes sense. Alright? So basically that is it. Very good?
Yes, sir.
You know the answer is correct. I want you to practice to check your answers that way for me, please. So that finishes that one. Alright, so let me go now and look at the next paper, which is 2022. I'll do the January ones. Next week, we'll do the June ones. Alright, we're doing the January ones today. Next week, we're going to do the June ones. Alright, that way I can keep track of what we have done. Alright, so this is the 2022, January 2022 exam paper. Alright, and this is another vectors question. Let's see what this one says. This one gives us a grid. It says OP and R are shown on the grid below. O is the origin, so the origin here. And then these are 2 points. Alright, based on the diagram, what are the coordinates of this point? It is 5, 1. So this point is 5, 1. Let's put over here. R is a point 5, 1. And P, what is P? Negative 2 up 4. So P is the point negative 2, 4. Now remember, the position vectors will have the same values. And here I told in class that they will ask you a question like that. See? Write the position vector of R, OR. I told you. So give me the point, you know. See the point here now. And I want the position vector. The position vector is this vector right here, the straight line vector. Having these two components. So it's 5 to the right and 1 up. And see that they want it in that form. So you can write it OR. No calculation this. You write. Just write it. You don't need to calculate anything. Is 5, 1. Just like that. Simple as that. 5 to the right and 1 up takes it from O to R. Alright? And we also know OP. So we can leave it right. If you didn't ask for OP, you can write over here on the side. OP would have the same values as the coordinates. Negative 2, 4. Negative 2, 4. Even though they didn't ask for that. But that is it. If you wrote the two of them, they still have to give you the marks for that one. Then the question says, another point Q is located such that QR is 2, negative 4. And I want us to use information to plot QR on the graph. What does this mean? This means to go from Q to R, you got 2 to the right and 4 down. From Q to R, you know. Remember, we don't know Q, you know. So, if this takes you from Q to R, then R to Q. So, since we know R, it's better to get to Q by using a vector to see where Q is. R to Q would have to go the opposite direction to that. It would be minus QR. So if Q to R is this, then R to Q is minus 2, positive 4. The negative of this. If you go from Q to R, you go 2 to the right, which is what that means, and 4 down, which is what that means. Then to go from R to Q, you're going to go 2 to the left and 4 up. So we can actually construct this to find where Q is from R. See it here? I'm going to show you another way to do this question. Right? So starting at R, we can go 2 to the left and 4 up to find Q. See it here? 2 to the left is this. 2 to the left. And 4 up. From 1 to 5. 4 up is this. See there? 1, 2, 3, 4. It means that Q is right here. What are the coordinates of that point? 3, 5. Q is 3, 5. And you can check it if going from Q to R is really 2, negative 5. That's what I said. 2, negative 4. From Q to R is 2, negative 4. See here? 2 to the right. Them say Q to R is 2, negative 4. So see there? 2 to the right and 4 down. 1, 2, 3, 4. So it means that this is the right place for it. But let me show you another way we could work out where Q is. By doing what? By splitting this vector equation into position vectors. I told you about that. Alright? So that's one way to do it. Doing it. But we can actually find Q another way. Remember, you know, if we find a OQ, then it means that we also know what Q is. Because OQ and Q will have the same coordinates. So I'm going to split this vector equation and show you another way to do it. Alright, let's look at it. So QR is 2, negative 4. I want to split this vector equation. Split. Into position vectors. So split this into the position vector that it would be, which would be O times the last minus O times the first. So it will be OR minus OQ. Minus OQ. And that is equal to this thing. 2, negative 4. So this thing split out to that. O times the last minus O times the first. What it is trying to find this? Trying to find this, you want to make this be the subject. So to make that the subject, you can take this and bring it over this side. Make it positive. And then take this and bring it over this side. And remember that the OR right now the OR right now, we have it up here. It's 5, 1. Right? So we can do it this way. Bring this over here, so we want to get OQ on the right side equals OR and then this now when it comes over it becomes minus 2 negative 4 and then this OR you can see it is 5, 1, right? Minus 2 negative 4. That's what OQ is. And then 5 minus 2 is 3. And then 1 minus a negative 4. This becomes a plus. Minus minus here becomes a plus. So like 1 plus 4 is 5. That's what OQ is. So the portion vector of Q is 3, 5. Therefore, the coordinates of Q is 3, 5. So Q is at the point 3, 5 on the graph, which is where we'll have it up here. 3, 5 up here. But you see in this example, it's easier to just use the translation type movement between the points, right? Because you know where R is. They're telling you to go from Q to R. You got 2 to the right and 4 down. It means then to go from R to Q, you go the opposite way. You got 2 to the left, which is minus 2, and 4 up to go from Q to go from R to Q. And why would I go from R to Q? Because I know where the point R is. And that's a nice, easy way to go from R to Q, to find where Q is. To just go from R to Q using the inverse of this vector. And that is it. But understand that? So this is like an OR method. I would not do this one in the exam. I will show you it could work that way. Right? I would use this diagram this way. I would use this and show you that I'm just going from R to Q to the left 4 up and find that point on the graph. Understand that, guys? Understand that?
Yes, sir.
Alright. So when you practice and learn these skills, you really fully understand these things by practicing questions, guys. Right? So, you know, not everything we're able to cover in the theory part, but we'll cover a lot while practicing questions. Anything else we have to do? This, as I tell you, this is now what the modulus. What the modulus of QR. It's the length of the vector QR. What is the vector QR equal to? They just gave it to us, right? This 2, negative 4. So QR is 2, negative 4. So the modulus is the length of the line QR. So the modulus of QR, that's what this is, the length of the line, is equal to the square root of this value square, which is 2 square, and this value square, which is 4. If you put negative 4 squared, it's same as 2 squared, but you don't need a negative. Alright? That works out to be whatever it is. The square root, this is 4 plus 16. Which then becomes the square root of 20 units. Modulus is the length. You can see it in the diagram. To go from Q to R. This is it. Look at the diagram. Q to R is this. You want to find the length of the modulus of QR is the length of this line right now. This side is 2 units long. And this side is 4 units long. So Pythagoras theorem can be used to find this length. It becomes the square root of this side square plus that side square, or the other way around. 2 squared plus 4 squared. It becomes square root of 20 units. So we could use Pythagoras theorem on the diagram and do it as well, right? But that's it. We have to know to calculate modulus, guys, because they won't ask you to do anything else with it. They'll just ask you to calculate it. This one now says, show by calculation that OPQR is a parallelogram. Alright. And they like to ask this. They like to ask to show parallelograms. Now what you have to do to show parallelograms, guys, is to show that the opposite sides are equal vectors. The opposite sides are equal vectors because they are equal in length and parallel. To show that OPQR is a parallelogram, if you show that the opposite sides are equal vectors. That's what you have to do. Every time CSEC asks you to prove a parallelogram, that's what you do. show that the opposite sides of that parallelogram or the quadrilateral are equal vectors. Alright? So let's look at it and see what we have to show. So OPQR. Alright, let me sketch stuff for you. So O right here, so now. So we're talking about this parallelogram here. So. What are the opposite sides? OR and PQ are opposite sides. So if you to show that OR are hold on a sec, guys. Hello? But I'm in a class online. Yeah, it's finishing soon. No, they're supposed to be doing something for you today. Alright, I'll check. No, alright. I'm in the middle of class now. Soon finish, I'll check. Yeah, cool. Yeah. Alright, guys, sorry about that. Alright. So as I was saying, to show that this is a parallelogram, I have to show that the opposite sides are equal vectors, right? So we know OR already. We need to show now that PQ is the same as OR. That's the first thing. So we have to show that PQ is equal to OR. And what is the OR? The OR is this 5, 1. So we need to work out PQ and show that it is 5, 1. And the opposite sides as well. We need to show that this side and this side are equal as well. That's these two sides. So we need to show that RQ is equal to OP. So we need to show that RQ is equal to OP, and that OP is negative 2, 4. Negative 2, 4. Alright, that's what we need to show to prove that that is a parallelogram. Now we're almost gone 3/4 of the way, because we already wrote down RQ right here, so from the QR, because RQ is just the inverse of QR in vectors. The inverse of a vector is the negative vector of the same, negative of the same vector. So basically then we already show this part of it. As you write down OP here, so it's negative 2, 4, and the RQ is negative 2, 4. So we already have that part. So the part that we need to show right now to finish the task is what PQ is, which we did not find PQ. So we have to work out PQ and show that it is 5, 1. Alright? So this is what we need to show to prove that we have a parallelogram. Copy. Paste down here. And I say they don't give a lot of space to work. Right? They don't give a lot of space. But I'm just writing out what we need to show down here. And then I'm going to put the solution in blue. So in blue. I put this on the paper, I know. I'm leaving this on the paper. To show that this is a parallelogram, this is what I need to show. I'm leaving this on my exam paper. Alright? So I already have this. So I'm going to write, we have this RQ already equals OP already, which is equal to negative 2, 4. Because I have it in my work. I stated this here, which is on my paper, and I stated this here, which is on my paper. Remember, if I'm doing this exam, I'm not going to do this part this way, I'm going to do it this way as I told you. Quite easier. Alright? And then now, I already have the first part of what I need to show. So I can put a tick on this one. This one is done. I need to work out this one now. To work out this one because I already know the OR. I already know the OR from up here, from the first question. Right here. I just need to work out what the PQ is. So when I say now, the PQ is OQ minus OP. That's O times the last minus O times the first. The OQ is 3, 5 because the coordinates of the point Q is 3, 5. So OQ is 3, 5. minus OP is negative 2, 4. Remember, OP is negative 2, 4. Here, negative 2, 4. So, means then that this works out to be 3 minus give a plus. This minus is a plus. 3 plus 2 is 5. And 5 minus 4 is 1. This is PQ right now, you know. It equals 5, 1. And 5, 1, yes. 5, 1 is OR. So this now is a proof of the first part, that PQ is equal to OR, which is 5, 1. So I have now successfully shown this. Therefore, confirmed. OPQR is a parallelogram. That's it. And every time CSEC asks you to prove that something is a parallelogram, that's what you have to do. You have to show that the opposite sides of that parallelogram are equal vectors. Once it's a vectors question you're doing and it asks you to show that the opposite, you have a parallelogram, that's what you have to show. The opposite sides are equal vectors. Just work out the vector on the opposite side of the parallelogram and they must come out to be the exact same thing, because they are equal in length and parallel. When vectors are equal, when two lines have the same length and the same direction, they are equal vectors, meaning that they are parallel and equal in length, and that's a property of a parallelogram. A parallelogram has two pairs of equal opposite parallel sides. So that's what you have to prove. But you understand that?
Sir.
Yes, yes, sir.
Alright, good. So a question like this, you're going to redo it for me. Please, go and do it again. Work it over by yourself. Alright, that's 2022. Let's look at 20. Alright. I think that I want to do, look at there's a particular question I want us to, I don't want to end the session without doing that question. So let me go for it. I think it's 2018. So let me go for it. I really want us to I want to make sure we do this question. 2018. But I like to set parallelogram questions. Alright. The vector parallelogram questions. I think 2018 and so on. No, not 2018. It's 2019. Let me see if it's 2019. I think it's 2019. 2019. Let me see. January 2020. Ah, there you go. 2020. Alright. Alright, so I want us to do this question. Alright, let's do this question, guys. I like to set this question like this. Sometimes I put the point up here, sometimes I put it in the middle here, sometimes I put it down here. I like to set parallelogram questions with the diagonal here. I might set one with the diagonal across here as well. Alright, and I put a point here, I'll put a point up here. But let's look at this one. Alright, let's look at this one, guys. This question says, PQRS is a parallelogram. Yes. So once it's a parallelogram, the opposite sides are equal vectors. So since this vector is V, up here so is V as well. And these two opposite sides, same thing. This side and this side equal in length and parallel. So they are equal vectors. So this vector is U. So this vector going up here is also U. Just like that. Alright? No calculation need for that. Simple because a parallelogram. It says PQ is a vector U. So this vector up here so is U. PS is a vector V. This vector across here is V. Alright? It says M is on the point QS. Watch this now, guys. This is the nice part now. Pay attention. M is on QS. The QS here right here, so M is on QS such that QM to MS is 1 to 2. See, this 1 to 2 are 3 parts total again, you know. 3 parts total. So what I like to do, so okay, QM is 1 part, put a 1 part there. and ms is 2 parts to the 2 part there. So total parts on this full line is 3. It means then that this piece is 1/3 of the entire line. 1/3. And this piece is 2/3 of the entire line. 2/3. So if I'm coming across this line, from here to here, it will be 1/3 of the whole QS. And if I need it, M to S will be 2/3 of the whole QS. That's what's going to happen in this question. They're going to ask for this line, and you have to come to here using 1/3, or come to here using 2/3. That's how these questions always go. That's what this information means. All right. It says write in terms of U and B, meaning U and B must be in the answer. U and V, sorry. An expression for QS. See? First thing asked for this vector, QS. But let me populate the diagram with all the vectors that we know. So since vector across here is V, as a parallelogram, then the vector up here is also V. Let's put it on there. This vector across here is also V. Underline my V. Then since vector up here so is U, then the vector up here is also U going up that way. So I'm going to put a U on here going this way. And now this question is asking us for the vector QS. Now, you know the position vector of Q and you know the position vector of S. So you can use that, you know. It is OS minus OQ. Because not O, no, it's P. P is the origin. So it's P we use, not O. P is the origin in this question. So it's PS. It will be PS minus PQ. Right? Which would be PS is V minus PQ be U. But you can also use the diagram to get QS. Go from Q to S. Look at the diagram. Go from Q to S. I can go Q to R first. And then go R to S. Now, the Q to R is just this V. And then R to S is minus U. Why is it minus U? Because I'm going in the opposite direction to the U. So the RS is minus U. So you could get it that way as well. See there too, from Q to S, you go V out here, so, and then minus U down there, so. Simple as that. Alright? So that's how we can get it. 1 mark for that anyway. Easy. So remember now that we know QS, it is as if we now know this road. We now know this road across here. And because we know it, we can come 1/3 of it using 1/3 of this, or we can go 2/3 of it using 2/3 of this. We can now travel along this diagonal road right there using this vector. Alright, let's see what else they want. They want the vector QM. Let's look. QM. Alright, so you see, we want QM. That's this little piece. So QM is just simply 1/3 of this. Easy. QM is simply 1/3 of QS. QM is just a part of QS. 1/3 of it. So it's 1/3 of the part and 1/3 of the part there. Easy. So it becomes 1/3 V minus 1/3 U. Alright? Simple as that. QM. The next part now wants us to show that MR is this. MR is this. And if we expand this out, you see what it would be? It would be 1/3 U plus 2/3 V. If you expand it out just to see what it is. Because normally you don't get the vector factorized like this. You normally get it with separate terms. So if we show this, then it means that we have that. So basically to show this, I need to just work out what MR is. And it must work out to be this, which would then be that. Alright? That's how we show this thing. So to show it, we're going to work out what MR is. We need to work out MR. Now, to work out MR, can we use O times the last minus O times the first? No, because we don't know OM. I keep saying O, but we're starting from P. We don't know PM. So we're not going to use the last minus first method. Right? Also, we want the vector MR. So the vector MR is from here to there. So we're trying to find this vector. But using vector direction that we know, how we do it? Remember, we know this road, guys. We know this road, so we have a problem. Going from M to R is same as going from M to S first, and then going from S to R. Can do it that way. Or if you like, we could go M to Q this way, and then go Q to R. Either way, I'm going to do 2 ways to show you. I'm going to do it both ways to show that the answer is going to be the same. Let's do the way we'll come down here first, and then go up here, which is my preferred way. Why is that my preferred way? Because I am going in the same direction as the QS vector that we know. That's why that's my preferred way. I prefer to travel in a way that is in the same direction of the vector that I know. Alright? Because when you go in the opposite direction, you have to introduce the negative. Alright, but let's do it. So let's write it out down there. Let's do it 2 ways. Alright, so we're working on MR 2 ways. Alright, so I'm going to put this over more to the left. So to go from M to R is same as going from M to S and then S to R. Let's confirm that's what we said. Right, we're going from M to S and then S to R. Now, the M to S right here is 2/3 of QS. 2/3 of QS. Let me write it. 2/3 of QS. Bear with me now. This is 2/3 of QS. This is 2/3 of QS. Plus the SR is just U. See there? The S to R is just this vector U. So adding U. But what is 2/3 of QS? What was QS again? QS, remember, is V minus U, you know. See there? QS is V minus U. Where is it? See there? And we're doing 2/3 of it right here now. 2/3 of this. So basically it is 2/3 of the V minus 2/3 of this U. And you're adding back this U to yourself now. So this is this, you know. And you're adding back this U plus U. And this simplifies into 2/3 V. That's the only V term there. 2/3 V. And then these two now gives you 1/3 U because this is a whole U, you know. So a whole U minus 2/3 U give you 1/3. A whole minus 2/3 is 1/3. Right? So it becomes plus 1/3 U. So it's telling me to go from M to R, I can go 2/3 V and 1/3 U. Let's check if this answer makes sense. 2/3 V, 1/3 U. 2/3 V, 1/3 U. So this is M to R is 2/3 V and 1/3 U. That's what this is saying. So from here to here. So this is a whole V. So 2/3 V is about this length. Let me break it up into 3 parts, like so. So 2/3 V will be about here. That will be 2/3 V. Alright? So I can copy this piece and put it up as 2/3 V right now. See if it makes sense. Ah, nice. So 2/3 V basically carry me out onto this line right there. And if this is a whole U, you can clearly see that this piece is about 1/3 U. About 1/3 of this whole line. So it is true. 2/3 V and 1/3 U take me from M to R. So I can accept that answer as correct. It is consistent with my diagram. And that's a little check I wanted to practice making. But we did M to R a while ago by going from M to S and then S to R. Let us go the other direction just to prove to you that the answer will be the same in the end. If we choose to go from M to S the other way. So if we come up to here first and then go here. Let's look at it. Let me do it on the screen right here. So doing it that way, I would say going from M to R is the same as going from M to Q first and then going from Q to R. But you see this MQ? This MQ is just minus QM, you know. Right? is just the opposite of this, or the inverse of this, QM, which is this, We're going in the opposite direction, right, to this. So if this is QM, look at it. If this is QM right now, then MQ that we're trying to find at the top is just the negative of this. So negative this and turn this into a positive. So it will be minus a third V plus a third U. Because MQ is minus QM. Opposite direction. Same vector, opposite direction in a sense. Right? So this is my MQ. Minus a third V plus a third U. So let's put it here. So this is minus a third V plus a third U. And then QR is right up here, so just a V. So I'm going to add a V now, plus V. Right? So this 1/3 U come back. And then this V minus a third V is 2/3 V. A whole V minus a third V is 2/3 V. And you're adding this 1/3 U. It's the same answer that we got. 2/3 V and 1/3 U takes it from M to R. Same answer that we got, even though we went in the other direction. Answer is the same. 2/3 V, 1/3 U. See there? 2/3 V, 1/3 U. 2/3 V, 1/3 U. Put a line here and copy that down as the other method, the other way, going in the opposite direction. We get the same answer. So let's cut this and paste it down here. There you go. Same answer. Alright, then we'll come to the sugar part now. It says T is the midpoint of PQ. Prove that R, M, T are collinear. I think I'm going to stop the class with this question today. Now I'll leave this one on your brain. I'm going to end it now at 12:20. I don't want the class to be too long. I'm going to stop it there after this question. I'm not going to do it anymore. Others will be done at some point. All these questions I'm going to be doing again, And the ones that we have not yet done, they're all going to be done again at some point before exam. I promise you. And you're going to have to do them under exam conditions as well. But alright, this one now says T is the midpoint of PQ. Prove that R, M, and T are collinear, meaning that R, M, and T are on a straight line. Alright? So let's go. So T is the midpoint. Let's put on a diagram. T is the midpoint of PQ. Let's put on a diagram. So let me take these off. I don't need these anymore. So T is the midpoint of this line. So it is right in the middle here somewhere. Let me put it on in blue. Let me put it on in blue. Right where that arrow is where T would be. So let me put this to a T. That's where the point T is. Now, if T divides this line half and half, remember the whole vector was U a while ago, Let's put on back the vector now in red. So it means that the vector from here to here is half U. And the vector from here to here is the other half U. Alright? So T to Q is half U. And P to T is half U. And the question is saying we show that these 3 points are collinear. Let me put on in blue. So you can actually see there on a straight line for real. See there? These 3 points, T, M, and R, are collinear. Those 3 points are on the same straight line. They are collinear. To prove that 3 points are collinear, you need to find 2 vectors between the 3 points that are parallel, and there will also be a common point. You need 2 vectors and a common point. Alright? 2 vectors, 2 parallel vectors and a common point between the 3 points. T, M, and R. So it means that you can't do this proof and bring in anything with Q and S in it. You need 2 vectors between these 3 points. And most times sometimes you'll have both of them already that you can use, and sometimes you'll have one. But because they just introduced in the point T, it means that we don't have a vector with T in it as yet. We have a vector MR already, which we can use. We have it already. Right? So we're going to use the vector MR, which you just found right here. We're going to use this vector MR. Let's write it down. So to prove that these 3 points are collinear, we need 2 vectors between the 3 points. I want to use MR as one of the points there. As one of the vectors, sorry. It's 2/3 V plus 1/3 U. And you have to decide which other vector you use now. Just use the vector between R and M. Now we need the vector between M and the T, or the R and the T. Your choice. Let's look at the diagram and tell me which one you would use. Right? We already have the vector between these 2 points. The next vector we need is between T and the M, or the T and the R. Which one would you use, guys? TM or TR? Which one would you use? We already know that we have the vector MR already to use. We already have that vector. So the other vector we need is either TM or TR. Somebody tell me which one you would use. Would you use TM or would you use TR?
TR.
Huh? Somebody said something a while ago. Come on, man. Even if it's wrong, you want to learn something. Come on.
TR.
You use TR. Anybody else want to say why you would use TR? Why would you use TR? Aiden. Anybody else want to say what I do?
We already have two known vectors, V and R. We already know what TQ is, which is half of U. And V is parallel to the other V down here. So would that mean that we have two known vectors already? We should cut out most of the gap.
Beautiful. It's basically saying we already know how to go from T to R. To go from T to R was come up here so using a half V and just go half U and just go across here using the V. There's no calculation needed. It's there on the diagram. If you were to do TM right here, you have to calculate, because to get TM you have to work out this vector to come to here, and then this vector you have to add them. You have to do work. But to go from T to I, there's no calculation needed. It is obvious. It is half U plus V. Right? Because you use a half U to take you up to Q, and the V take you from Q to R. Simple as that. That is the reason. Right? So TR, even though it's a longer one, it is the easier one to find right now. No calculation needed. So we're going to be using the TR, which is half U plus V. Same as V plus half U. So down here, so we're going to use it TR, which is half U plus V. Alright, so we want to compare these two vectors now. Since this one has the V, hold on, this was a half V, 1/3 U. It's supposed to be a U, 1/3 U. Right, so since this one has the V in front, I'm going to put this V in front. So I'm going to write this TR as V plus half U. Alright, so to show up collinear points, we need to show that these two vectors now are parallel, and obviously R is going to be the common point, right? We have to first show that they are parallel vectors. And when you have these vectors with fractions in them, the first step I always say is that you get rid of the fractions first, because the fractions make it more difficult to see the relationship between the vectors in terms of a multiple. Because when they are parallel, one is a multiple of the next. So the first step is to get rid of fractions. And you normally multiply by the lowest common denominator, the fraction. In this one, the denominator is only 3. So I'm going to multiply this one by 3. I have to remember to multiply this side by 3 as well. So when you multiply by 3, multiply this by the 3, you get 3mr equal, multiply this by 3, it becomes 2v. Multiply this by 3, it becomes a u. And then to get the fraction out of this one, the first thing we look to multiply by is this denominator, which is at 2. So, yeah, 2 is a good number to multiply this by to get rid of the fractions. So, you multiply that by 2, you multiply this side by the 2 first, you get 2tr equal, multiply this by the 2, you get 2v. Multiply half u by 2, you get plus u. And you realize now that these two things are the same. And if those two things are the same, mean that these two things are the same. And that's why we can equate those two things now. They are already the same, so we don't need to be multiplying any up to be equal to any. Normally, if these two were not the same, then we multiply the smaller one by a value that will make it equal the larger one. Because you want to make them equal so that you can equate. You want to be able to equate. But because they are already equal, you can go straight and equate right now. Let's put that part in purple. So now we're going to equate those two vectors. So as I said, both of them equal that. So it means that the 3mr equals the 2tr. So you can write that 3mr equals 2tr. And so there are two things happening here now in this simple vector equation. Firstly, I could divide by the 3 here now and put 2/3, right? And then I put 2/3, and then 1 with 2/3 after other. But it don't matter, they can stay this one. That vector is a multiple of the next one. So because 1 is a multiple of the next, first thing condition is met. First condition is that they are parallel vectors, right? So you have your parallel vector. So MR is parallel to TR. That's the first condition for collinearity. For points to be collinear, you must have parallel vectors. The second thing is that there must be a common point. In this case, R is a common point there. R is on both vectors, so R is a common point. You put arrows on top of these vectors, right? So put that on top, right? Now, because you have these two conditions, parallel vectors with a common point, you can say, therefore, the points involved, which are R, M, and T, are indeed collinear. And that is your proof. That is it. I'm going to stop it there for today, guys. I'm not going to do any more. We did about 4 questions. That is enough for today. And I like the fact that we finished off with this particular one from 2020. Alright, the others that we skip over today, we'll do them some other time. Alright, and you guys have to keep practicing. So I'd advise you to go and redo these same questions that we did today first. So we did what? From the 2021 skip over, 2024, 2023, 2022, and then with the 2024 questions, which is enough for today. Alright, so go and redo the questions for me, please. Do them over. I want to extend the video and use it to help you get through. Alright guys, I'll see you all in class tomorrow and Monday. Alright everybody, have a great day.
That's it.